And it's recording. Okay, exercise 8D. Here we go. I want you, on your sheets, can you please write down the difference of perfect squares rule, which is normally known as DOPS. So when they say DOPS, that's what they mean. It is a squared minus b squared is equal to, and write this down, a minus b in brackets, multiplied to a plus b in brackets. It doesn't matter which bracket comes first. You could have wrote it as a plus b, and you could have wrote it as a minus b afterwards too. It's fine. Okay. So write down that rule first, and then I'm going to show you how it works. Most of you, by the end of my first part of the explanation, will be able to do A and B and 6 more in a few seconds in your head, because that's how easy it will be. Okay, so here we go. Now that you copied the first rule down, let's have a look at the first example. X squared minus 9. This is what your task is. If you ever recognize that you've got a square and then a minus, one of the first things you can say is that you're going to be using DOPS. Boys, I know you're talking about the problem, but at the moment I'm recording. So if you ever see a square and then you see a minus, that's when you know to use DOPS. So here's some examples. X squared minus. Have a look at this one. Squared minus. If you have a look at the next few examples, you see a square, you see a minus, you see a square, and you see a minus. That's when you know that it is a difference of perfect squares problem. Okay? So when you recognize it's a difference of perfect squares problem, this is all you do. So the rule says that you need a squared minus b squared, right? I want you to rewrite this expression, x squared minus 9, as, and always have this step ready. This will help you do even the harder questions. So set up this format for me. So equals, brackets, inside is blank right now, squared, minus another bracket that's empty, and then squared. Write that down first, okay? Because once you get that format correct, then the next line will be much easier to fill in, okay? This is how it works. If you see a difference of perfect squares problem, this is what you got to ask first. What do I square? Okay, what do I square in this bracket here to get x squared? So something times itself will give you x squared. What would that something be? What would that something be? Put your hand up if you know. What would that something have to be? Something times itself gives you x squared. What would you multiply by itself? X. So here, we know that x times x, so here if I write x times x, we know that's going to give you x squared. So the number here has to be x squared, or x. Let's have a look at the next bracket. What number would you have to multiply itself by to get 9? Yeah, 3. So in our case, it'd be 3. So you can see here, square of 3 gives you 9, and the square of x will give you x squared. Now, if you didn't know that, another way of thinking about it is square rooting both sides. If you square root of 9, you get a 3. And the square root of a square, they both cancel out because they are opposites. And you're left with an x. That's another way of sort of thinking about it. Okay? So, once you've got this set up, the answer is actually really easy. What was it? The rule was, if you know what A is and you know what B is, A is what's in the first bracket, B is what's in the second bracket. Then basically, you've got A minus B and then A plus B. So if I write it out, my A was x, so I write out my answer. I say, okay, so there must be x minus b. Well, my b is 3, so it's minus 3. In my second bracket, A again, which is x. The only difference is there's a sign, it's plus 3. You see, as long as I get these two terms first, so if you get the x and then you get the 3, it's easy to fill out that's x minus 3, then x plus 3. The mistakes come about not in the first 2 examples, but the next few because they don't set this one up appropriately. Okay? Let's do one more, just so you get the feel of the first 2. So if we have a look at the second one, same thing again. Let's have a look at B. I want you to rewrite it as square of something will give you the first one, minus square of another number that gives you 16. That's the goal. Let's write it out. Here we go. Square of what will give you x squared? Let's go with Lex. Square of what will give you x squared? X. So we put in x here. Then the next one is, well, I need a 16. So square of what will give me 16? Yes, 4. Now that you've got x and the 4 inside the brackets, you can follow the rule again. A is my x. So it's minus b, which is 4. And then a again, which is my x, plus my b, which is 4. And you're done. Are you starting to see the pattern here that when it's 16, it's 4? And it's x minus 4, x plus 4. When it was minus 9, then it was x minus 3, x plus 3. Can you see that pattern? Because what you're going to do now, I'm going to give you ones that you're going to do in your head. Okay, so here we go. Here are the most typical ones that all year 9s and year 10s will learn how to do this when I give them something like this in a test. If I said x squared minus 100, what would the two numbers be inside the brackets? Anyone want to have a go? What would be inside? X and 10. So it should be x minus 10 and... Very good. Let's do another one. What if I change to x squared minus 25? What are my two numbers in this case, Jack? X and 5. It will be x minus 5 and x plus 5. Can you see what I'm saying? That most students at year 9, year 10, once I teach this, they'll know it. You go to the exercise book and you'll be able to do every single question that is a squared number here. So 100 becomes 10. Square root of 25 is 5. You can think of a couple of other ones like 64. So if I gave you x squared minus 64, most students will know it is x and 8. So then you say x minus 8, x plus 8. So pretty good, yeah? But how can I make this harder? If you look at the second two examples now, so I've changed it just a bit to make it slightly harder. Same techniques. Here we go. Same thing again. Let's do C. So you're able to do A and B now. You're starting to see the pattern. But you see that intermediate step is going to be key. Let's have a look at C. Same thing again. Your question is, square of what will give you 4a squared? Okay, so square of what? Something times itself will give you 4a squared. Okay, what would that be, Lex? 2a. And be careful there. So a lot of students here just write 4a. But you see, if you actually multiplied 4a by 4a, it doesn't make sense because a times a is a squared, but 4 times 4 is 16. We don't want 16. We want the 4. So the numbers had to be 2 and 2. 2 times 2 will give you that 4a squared that you needed. Okay, so the number that actually goes in the brackets here should be 2a. Because we know the square of 2a will give you 4a squared. Then the next one's pretty easy. We already worked with 9. What numbers multiply to itself to give you 9? 3. So then we write 3. Now, once you've got that, then the answer in the brackets becomes easier. So you should have 2 brackets. Here's my first term. Here's my second term. So it should be 2a minus 3 and 2a plus 3. See that? So once you get them in the brackets and you've done it correctly, then these answers will be easier. Let's have a look at the D. D is the same thing. So your job is to figure out what numbers goes inside the bracket because you need something squared minus something squared. That's what difference of perfect squares is. So here we go. We'll do the same. What number multiply itself to give you 25a squared? Avia? 5. 5 what? 5a. Very good. So you can see here 5a times 5a gives 25a squared. What about the next one? Let's go with Kaylee. What would I multiply to get you b squared? B. Again, if you guys aren't sure, one of the ways to do it is you just square root both sides. So square root and the squares will cancel out, so hence you get just a b. And if you do this one, square root of 25 is 5, and then square root of an a squared, the squares cancel out, and you get an a. But the most important part is that step. Knowing what goes inside the brackets, because once you do, here's the answer. In the 2 brackets, it should be 5a, take away b, and it should also be 5a plus b. So far, so good? Yeah? So this is year 9 level. What do you see here in the first half? That's what they expected at year 9. So seeing how to do this, all of you should be able to do this one. Then the next bit is just whether you practiced or not. Okay? Now I'm going to increase it to make it a year 10 level. so that you can see, well, how else can I make this a bit harder? Okay, so here we go. If you look at my next two examples, and this is my last two examples here, one of the challenges that students have is that when they give numbers that aren't squared numbers, so the reason why before was easy, because you know your 9, square root of 9, square root of 25, square root of 64, square root of 100, you know these. What if they give you 32? Okay? In the year 9 and year 10 level, if you're sort of doing a bit harder questions, one of the things that they want you to pick out on, right here, 2b squared and 32, before you even do the problem, there's a common factor. If you factorize it first, it actually makes your life easier. Now, what's common about 2b squared and 32? What do they both have in common? 2. They're both an even value. So if you took out a 2, this will make out your life to be much easier, because 2 times what will give you 2b squared? Well, 2 times b squared. 2 multiplied to the b squared will give you the first term. But then 2 times what will give you negative 32? 2 multiplied to what to give you negative 32? 16. So in our case here, it should be minus 16. But can you see what I wrote in red? Isn't that similar to what I just did before with you? It's something squared minus another number. So you can use difference of perfect squares just within the brackets. So keeping the 2 on the outside, this is what some students may find tricky and they're not used to. You just focus on this. Sorry, Idris. Thank you. Try not to speak while I'm speaking. B squared minus 16. If you focus on only just this, whilst maintaining the 2 on the outside, we can do the same thing we did before. Square of something gives you the b squared, minus the square of something has to give you 16. So we do it again. What number goes inside here if I want square of something to give you b squared? What should that number be? B. Then the same thing, square of what will give you 16? 4. So now that you got the numbers inside the brackets, you can do exactly what I just taught you before. Difference of perfect squares. Notice I'm keeping it in green to color code it for you. The 2's still there. The 2's still on the outside. But I'm just factorizing the inside here. That would be my A. That's my B. So when you write it out, it should be B minus 4 and B plus 4. This is a typical example that if they wanted to push you just a bit harder with numbers that aren't square rootable, try to see if you can find a factor. Then you should be able to break it apart. Okay? Now, the answers, if you left it like this, looks intimidating. I would say if you just write your answer like this instead, I'm just going to make this a bit smaller. How about you write it like this instead? It might feel much easier. The 2 is being multiplied and multiplied to this number b minus 4, and then multiplied to b plus 4. So the best way to write it is like this. You don't need to write so many brackets. You can just write 2 on the outside, b minus 4 times b plus 4, and that's appropriate, and that's fine. Okay, so copy that one down. I've seen some students do it this, and usually only year 9 students start off like this. But after a while, you get better, and then we minus the number of brackets because it gets too confusing. Yeah? Now, before I move on to B, what happens, and this is not going to be in your, I don't think it's in your year 9 textbook, but if it is, how would you do this one? You know how to do x squared minus 9, x squared minus 100. What if I gave you x squared minus 7? Okay, so same idea. You need something squared minus something squared, and this is where some students get stumped. I want you to have a think about this for a moment. We know the number in here is going to be x, because square of x will give you the x squared, but square of what will give you 7? Square of what? Yeah. And this is where some students feel uncomfortable. We always feel like when you square root a number, it has to be a nice number. If it is, great. But if it isn't, it's fine. You can even type this in your calculator. You'll find that if you took root 7 times root 7, the answer is 7. Okay? Because the square and the square roots are going to cancel out. That is the answer. If you type on a calculator, it's a decimal. But it doesn't have to be a decimal number. We can leave it as an exact value. So usually, so I'll do a contrast so you can see. You know how when you were doing x squared minus 9, you are happy to write it as x squared and minus 3, right? The reason why you're happy with the 3 is because you know what root of 9 is. Root of 9 is 3. But what if you don't know what the root of that is? It's okay to leave it as root 7. Nothing wrong. See, I could have left it as root 9, but we just don't. Write it as 3. Okay? Same pattern. So that means your answer for this problem, what would it be? It would literally be x minus root 7, x plus root 7. Okay? Same thing. It's okay. It doesn't have to be a nice whole number like you're familiar with. It can be any number. It can be a fraction as well. But the pattern is always the same. You're always square rooting these two terms to get those two numbers. Now, this is probably year 10 textbook, but if you do happen to see an enrichment, then you know how to do it now. Okay, same technique. All right, here's my last example for today. And if you're game enough, you can have a go with the last one there where I tried to mix a lot of things together. But let's see if you can do this one. So same thing. This one, a lot of students, when I put on a test, students get scared and they leave it blank. But in fact, this is meant to be easier than the ones that you just did, especially these two. These two and these are actually harder than B. But B, a lot of students leave blank. Here's how you do it. Same question again. Something squared minus something squared. See, your goal is just to write in what fits in there, yeah? Now, here's the thing. The 9 we know. Square of what will give you 9? Square of what will give you 9? 3. So all of you will know this one. Great. It's this one that students get scared. Anyone have a clue what this might be? Yeah, because it's already squared. You didn't even have to do anything. It was already something squared. They've already done it for you. So you're in this pattern where you always have to write something squared. You don't have to. It's right there. It's x plus 2 all squared. So now that you've got the two numbers, all you have to do is follow what I showed you before with the rule. This is my A, that's my B. So all you have to write now is x plus 2, take away 3, and x plus 2 plus 3. These are my two possible brackets. Don't leave your answer like this. You want to simplify that. We do know what 2 minus 3 is. That's negative 1. And then over here, this is x plus 5. Okay, so I'll zoom out just so you can see. So see the two examples. Which one is easier to do? This one's so much easier. This one, students will have a crack. This one, they leave blank. It's just something about it. It's just the fact that putting an extra term makes it scary for a lot of students. But that, if you're looking at this and you're going, oh, it's not too bad, that's really good. Because that is, year 10, we do the exact same thing. And then year 11, I still teach them again. Same thing. Okay, so the kind of problems you get at year 9 may not reach this level, but it's the same technique for all of them. Okay? So again, keep in mind, if you can't square root it, leave it as a root 7. It'll be the same for the next one if you wanted to have a go. That 5, you can leave it as root 5. There's nothing wrong. Okay? I'm going to stop there. That is all for today's lesson. I'm going to have this table up here where I'll call up some students and I'll work with these examples to make sure that you're sort of learning 8D and you're sort of comfortable doing it independently. But this is your session. Here we go. I'm going to stop the